Hey everybody, welcome back. So first off, I want to say if you didn't understand or get through all that NumPy stuff last time, don't worry about it, it's okay. It was a pretty long video, and we're going to explain every single thing we do anyway, so don't worry about it too much. Today, we're going to look at, again, something that you don't need to fully understand, but at least get an idea around, is being able to dissect certain components of, say, a matrix. Okay, so these arrays, it's a bunch of values, and so you could think about that. We said we could reshape it to actually fundamentally change the shape, although keep the same elements. But keeping the shape, you can just extract certain components of it, and of course that'll give it a different shape, but it's not actually changing this matrix itself. So if that doesn't make sense, let me just show you what I mean. You can think about it, a matrix, in a couple different ways. You could think about it as two rows, or, well, this one in particular, 2 rows, or 2 columns. And we can get these things very easily. If you think about it as a list of rows, well then M0, that is the first row. Okay, and notice it says array here, so we know that's an actual numpy.array object still. So that's the first row, pretty much the same as NumPy or normal Python syntax so far. If I had the list of 1, 2, and then 3, 4, this is the equivalent thing in Python. And if I was to say, get me the first thing of that, this is exactly the same thing, really, just in Python. And that gives you the same thing, but it's a list. Okay, so we could do that, and equivalently, we could do M1, or similarly, we could do that to get the second row. And if we had this thing here, M sub 2, well, that's not in bounds. Okay, we don't have a third row. So that's an easy way to get the rows here like that, and there's various times we might want to do that. And let me just get rid of this to be clear. We can also think about it as columns. Okay, so this matrix M has 2 columns. If I was to ask for the first column, I would specify that I want all of the rows. Here's the colon here. Colon means all. And so I want all of the rows. So 1, 2, and 3, 4. But now I specify what columns I want. If I wanted all of the columns, well, this is all the rows and all the columns. So that's just everything. But if I wanted a certain column, I could say, no, give me the first column. And so that's how I get that right there. And notice the shape of it here. So this thing's dot shape, you can see it's just the standard with a comma here. It's just a list of 2 values basically, but an array. So it's not, it's not like a column vector, or it kind of is. Again, it's a weird discussion in NumPy what these things actually are, but it's not a big deal. Just note that's what it is. And we could also get the second column like this. All right, so that's how we would get either rows or columns. We could also dissect or gather specific elements. So if you wanted just one thing, I could say in the rows, well, I want the first row, and I want the second element. So this is 1. So I say the first row with the 0, and then the second element of that is this 2 here. So this should say 2. And notice that this one, it actually is exactly the value of 2. And so if I ask the type of this thing, it is straight up whatever data type it is, which in this case is a NumPy integer, which is just an integer in NumPy. Okay, so that's how you might diagnose or select certain components of a matrix. I doubt you'll be surprised to hear that you can do this with just normal vectors as well. So if we had, again, A, which this is a straight up column vector very specifically, we could ask, say, the first component of that, A sub 0, is note that we're going to get an array back in this case. It's like the array of 1, so it has a shape of just 1 comma, kind of weird. Really, it means an element, but specifically, we're getting back the array of this thing here, and so it's still an array. But if we instead had just kind of the normal, like the NumPy normal way of doing it is just the array. If we had the array of, say, 1, 2, 3, okay, so if I said maybe C is equal to this thing, and I'll output that for you. If we were to ask the shape of that thing, it would just be 3 comma. And so we could ask, say, C sub 0. So the first thing of that is, again, like before the matrix thing, it's getting the actual element of that. And that's exactly what A0 up here is doing, except that actual element is actually an array instead of the value, even though it's only one thing. Okay, so there's some more types of things you could do with this. Technically, you can iterate through with these things. I could say if you had the matrix M, I could say for I in range of the length of M. So actually, let me do it this way. if I got the shape very clearly as m shape is equal to m dot shape, and so just to print it for you, print m shape, even though that'll fail, it'll still print it for me. No, it won't, I lied. So m shape is 2, 2, as we know. And so technically you could iterate over these to get all of the elements and look at each of the elements. You could say for I in range of the m shape sub 0, because that'll be the length, how many rows we have, that's 2. And then we could also say for j in the range of m shape sub 1, okay, so that's how many columns we have. So then this thing will actually gather each element. If I was to print m sub I j, okay, if I was to print that, then that is going through all of our elements. But in NumPy, we rarely do that if the array is even slightly big, because the whole point is to do this, what we'll call parallel computing, and talk a little bit about that, is we're trying to make the computer do stuff at the same time. And if we actually force this for loop here, if we write the code like this, that's telling the computer, no, you have to go through this one, then this one, then this one, then this one. Whereas with linear algebra and NumPy stuff, if you do some other operations, it's going to be like, no, I can do this in parallel. I can work on the first element and the second element and the third element all at the same time. And if, again, you don't understand that conversation too much, don't worry about it. I'm not going to go too much into the idea of vectorization from a mathematical computation point of view, just in general what it's doing. And yeah, so I will see you in the next video. Hopefully that made sense, how we can work with the various shapes and getting these different elements from our arrays or matrices or whatever kind of array element that we have.